In this video, we're going to learn how to plot points on a coordinate plane and determine the quadrant that they're in. Often the coordinate plane might be called a Cartesian plane or an XY graph, XY coordinate plane. We're going to determine whether an ordered pair is a solution of an equation in two variables, and we'll take a look at what an ordered pair is. And then we'll find the missing coordinate of an ordered pair solution given one coordinate of the pair and an equation with two variables. The second objective here, determining whether an ordered pair is a solution. As you get later on in this unit, this will basically become what you will do to check your work, but it also provides a framework of understanding of what's going on as we begin this unit. And in the third objective here, we're going to look at an ordered pair and what they are in a little bit, but they have two different values. One will be given, you'll find the missing one. Okay. We begin by taking a look at the Cartesian plane, or coordinate grid. It's a graph, and it's used to show the relationship between two variables. The horizontal axis, which has arrows that extend in both directions, left and right, is the x-axis. The vertical is the y-axis, and so the two variables that we're comparing are x and y. The point of intersection of the x and y axis right here at this point, this is called the origin. And this Cartesian plane is divided by the axes into four quadrants. And we use Roman numerals to number these quadrants. We start in the top right. That's quadrant 1. And we work counterclockwise, quadrant 2, 3, and 4. An ordered pair, which I spoke about moments ago, is a single point found on that Cartesian plane, and ordered pairs are in the form x, y, with a comma to separate them, and they are in parentheses. This is different than interval notation because it represents a specific point on the graph, although it looks like interval notation from last unit. The first value is the x-coordinate, and the second value we call the y-coordinate. And we'll explore some points on a graph on our next slide. In this example, we're given 6 ordered pairs, which represent 6 different points on this graph, and we will plot those shortly. I'll show you how to do that. First, when you see a graph like this, it's important to always label the x-axis if it is not already labeled, and the y-axis if it's not already labeled. Then, it's important to identify a scale. What do each of these lines mean? So we take a look at the first coordinates in each here, the x values, 3, -2, 7, -4, 0, -1. And we see 7 is the largest and the smallest is -4. We have plenty of space, so we can go by 1 long. So each one of these will be 1. And instead of writing 1, 2, 3, 4, you can just say that this is 5 and this is 10 instead of labeling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anybody can look at this graph and see, oh, they're going by ones. And similarly, -5, -10. We check on the y-axis. 4, 1, -3, -2, 5, 0 are the y-coordinates in each of the ordered pairs. So the lowest we have is -3 and the largest is 5. Again, plenty of space on this graph, so we will go by ones as well. This would be 5, this would be 10, -5, -10. Okay, now that this coordinate plane is labeled with a scale and the x and y axes are labeled, we are ready to use it. The first ordered pair that we're looking at, 3, 4. We remember x, y is how the ordered pairs are listed. And so for point A, we're going to start at the origin, which is 0, 0. Both the x value being 0 and the y value being 0. This special point, again called the origin, will start there. And we need to go to the x value of 3. 1, 2, 3. And a y value of 4. So we go from 3 up to 1, 2, 3, 4. This is point A. Some teachers in early math years, you might remember back in like middle school, hearing as you're plotting points, you have to crawl before you can stand tall. So that means go horizontally on the x-axis before you stand up onto the y. That might be helpful for you. The second point, the x value is -2, so again we start at the origin or the beginning, a good starting point. And we go from 0 to -1, -2 on the x axis, and then up to +1 as our y coordinate. This is B, point B. You might think of playing the game Battleship, where we have to find the number and the letter to where those crosshairs are. That's the same kind of concept with plotting points, or we look at the latitude lines and the longitude lines and where do they meet on a map. This is very much the same process. We just have an x direction and a y direction, and we find where those lines meet. Point C, an x value of 7, x coordinate of 7, so 5, 6, 7, and a y coordinate now of -3, so we're going to go down 1, 2, 3. This is point C. Point D, -4, -2. Again, start at the origin or the beginning. We go to -4 along the x-axis, and then down to -2 in the y direction, and that is point D. Point E is at 0, 5. Now this one's a little tricky. We start at 0, 0. And if the x coordinate is 0, that means that we move left nothing and right nothing. And so this point is going to be along the y-axis. Later you will hear us call points like that y-intercepts. When a line crosses that axis, the point at which that happens is called the y-intercept. And that is at 0, 5 in this case, so this is point E. Point F is an x-intercept. If it was the point where a line would cross that axis or a graph would cross the axis. Here we have an x-coordinate of -1, but then we have the y-coordinate of 0, so we don't move up or down. We stay right here for point F. At this point, I want to kind of revisit the quadrant, each quadrant. Again, this is quadrant 1, starting in the upper right, and then moving counterclockwise, quadrant 2, quadrant 3, quadrant 4. Quadrant 1 is the quadrant where both x values and y values are positive, and so that's a good place to start. So point A is in quadrant 1. Point B, quadrant 2. Point C over here is in quadrant 4. Point D is in quadrant 3. Point E is on the y-axis. This is not in the first quadrant or the second quadrant, it's on the boundary. So we'll say on the y-axis, not in a quadrant. And point F is on the x-axis, again between quadrants 2 and 3. So it's not in one of those quadrants, it's just on the x-axis. So now we'll take a look at linear equations, this time in 2 variables. In previous units, they've only been linear equations in 1 variable, but now we have an x and a y. And the equation ax plus by equals c is going to be our standard form. A, b, and c are real numbers. The variables are x and y. An ordered pair is a solution to that linear equation in 2 variables. It's the x and y value that satisfies the equation, creating a true statement. And we'll explore that as we look at determining in these examples if the given ordered pair, in this case 6, 2, is a solution to this equation 2x minus 3y equals 6. So we substitute 2 times 6 minus 3 times 2 equals 6. We took the x coordinate and the y coordinate and substituted those in for x and y in the equation. Again, it's a good habit to get into to use parentheses every time you substitute a value or an expression into an expression or equation. 2 times 6 is 12. Negative 3 times 2 is negative 6. And that equals 6. Okay. 12 minus 6 is 6, which equals 6. This is a true statement. So it checks. The point 6, 2, that ordered pair representing that point, is found along the graph of this line. This math that we just did will be a check for you as you're working through later questions. You can substitute your answers in when you're asked to find the ordered pair. Substitute those answers into the equation and solve, work out just as we just did to see if that solution, or if you get true statements. If your statement is false, you may have had a mistake, or the point may not be on the line. Example 1b. We have an x coordinate of negative 2, a y coordinate of negative 8, which we will substitute into our equation. 2 times x, which is negative 2, equals 2 times y, which is negative 8 minus 4. 2 times negative 2, negative 4. 2 times negative 8, negative 16, minus 4. Negative 16 minus 4 is negative 20. Negative 4 does not equal negative 20. This statement was false, and therefore the point negative 2, negative 8 is not on the line 2x equals 2y minus 4. Our second example, I give you an equation and a coordinate that is incomplete. In example A, we have an x coordinate, we're missing the y coordinate. So we're going to take that x value, substitute just the x value into the equation, and solve for y. 14 times 2, which is 28, equals negative 7y. That is y has a coefficient of negative 7, so we're going to divide by negative 7. Y equals negative 4. And that is the value that will be substituted up in here to get 2, negative 4 as the point that is on the line defined by negative 7y equals 14x, the point 2, negative 4. Example B, this time you're given a y value and you're looking for the x value. So we take negative 2 and we'll substitute it in for y. X minus 5 times negative 2, representing y, equals negative 1. And we'll solve for x. Negative 5 times 2 is positive 10. Subtract 10 from both sides. X equals negative 11. So the point asked for, negative 11, negative 2. That is the complete coordinate for the point on the line defined by x minus 5y equals negative 1 when the y value was negative 2. Let's go a step further. Here's a table of values that's incomplete for the line defined by the equation y equals 2x minus 10. For 2 of the 3 points, I'm given x values, and for one of those points, I'm given a y value. We will substitute x or y, depending on which point we're working on, into the given equation to find 3 complete ordered pairs in this table. And the ordered pairs are kind of disguised in the table this way. X coordinate, y coordinate. But there are 3 points. So in a sense, we're doing the same work that we did in example 2, now just multiple times per question. So the first one, we're given an x value. Y equals 2 times 4, which was the given x value, minus 10. 2 times 4 is 8, minus 10 is negative 2. So 4, negative 2. The next time we're given a y coordinate, so negative 20 equals 2x minus 10. So we'll add 10 to both sides of the equal sign and get negative 10 equal to 2x. Divide by 2, x equals negative 5. And the last, we're given an x value of 5 again. Y equals 2 times 5 minus 10. 2 times 5 is 10, minus 10 is 0. And now our table is complete with 3 points that can be found on this line, this given line. The process of completing a table of values, similar to our last example, is helpful when we graph linear equations in 2 variables. One method is to use a table of values, and that's what we're going to explore in this next example, graphing the equations of lines in 2 variables using a table of values. The graph will be a pictorial representation of the set of all points that, quote, satisfy the equation. Meaning, as in previous examples, if we were to substitute the x and y coordinates back into our equation, we would get a true statement for any point all along that line. That's what it means by satisfying the equation. A linear equation in two variables will form a straight line when graphed on the Cartesian plane, and the table of values is one way to generate the set of coordinates that would lie on that line. In example 4, we'll take a look at doing just that. So we will set up our table x, y, and we'll select some x values for that table in just a moment. Let's go ahead and get our xy axis labeled y, x, and let's get our scale. We'll go by 1 again, and so 5, 10, positive 5, positive 10, negative 5, negative 10, negative 5, negative 10. And I choose those numbers to write just because the entire graph goes out to a positive value of 10 or negative 10, and halfway is 5. So if our graph was smaller, I might have chosen to write 8 and 4. There really is no specific way for you to label that, just that there's something to indicate that you are understanding what each of those lines mean, and that way somebody else could also read your graph and know what each point means. So 2x plus y equals 4, and we'll pick some x values. Let's try negative 1, 0, 1, and 2. 2 times negative 1 plus y equals 4. 2 times negative 1 is negative 2, plus y equals 4, plus 2, y equals 6. So negative 1, y equals 6. 0. 2 times 0 plus y equals 4. Whoops. Got ahead of myself there. 2 times 0 is 0, so that's gone. And we have just y equals 4. As you continue to do the algebra, you will find that when you substitute 1 in, you will get 2, and when you substitute 2 in for x, y will be 0. Now that I have those points, I can plot them. Negative 1, 6, 0, 4, 1, 2, 2, 0. And you see this line starts to take shape. I'm going to do my best to graph this line without a ruler, because I can't get a ruler or straight edge onto the screen. So I'm freehanding this here. It's helpful that you would extend your line all the way through the given coordinates, or the given coordinate grid, as I did here, regardless of your points. You don't have to necessarily plot out all of, create a table of values to cover all of the possible points on the given axis. You just need a few, and once you have them, set up a ruler or straight edge along those points and extend your line all the way through the graph as I did. We're going to do or graph letter B on the same axis here, and I will do that in black. Yes. Okay. Y equals 3x minus 1. X, y. Again, we'll choose some values. 0, 1, 2. And when we substitute 0 in for x, y equals 3 times 0 minus 1. Again, 3 times 0 cancels out, and y equals negative 1. For the next one, we'll substitute 1. For x, 3 times 1 is 3, minus 1 is 2. So y equals 2. And for the last point that I've chosen, y equals 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. So we'll plot those points, 0 on the x, so I don't move left or right at all, and I go to negative 1, go down to negative 1 along the y-axis. This was our y-intercept of this line. Then we have 1, 2, happens to be the same point as this other line that we had graphed. And then 2, 5. So those are the 3 points from our graph. And again, I'll do my best to graph this line. As straight as possible. This is line B, and maybe we should label them since we've put two separate lines on the graph, and there's line A. Two more lines to graph here as we close out our lesson. Sometimes people write their table of values this way. So this is another way to represent x, y. And they write the equation in the middle, and they use the middle space for the work. So again, choose some values here, negative 1, 0, 1. And in our work, we'll say y equals 2 times negative 1, which is negative 2. Y equals 2 times 0, which is 0. Y equals 2 times 1, which is 2. And so we'll come over here, y, x, and we'll label a scale. I'll do it a little different this time. We're still going by ones on the axis, so our scale is still by 1. We're just not writing every single number, just putting enough so that everyone understands what this picture will be representing. And then we'll go ahead and graph negative 1, negative 2, 0, 0, which again has a special name, the origin, and then 1, 2. So x value of 1 up 2 to the y value, or y coordinate. And again, I'll do my best here to graph this line. Example D. X, y, and for time I'm not going to rewrite the equation, I'll just kind of put it in there. when the equation is long like this, you might choose special values like 0, which I've chosen every time. 0 is one that will create less work and therefore eliminating potential error. We'll substitute 0 in for x. 15 equals negative 5y plus 3 times 0. 3 times 0 is 0 and will go away. And so we just have to divide both sides of this equal sign by negative 5. And then y equals negative 3. And if we put 0 in for x, there isn't anything telling us that we couldn't substitute for y. So let's substitute 0 in for y and see what happens. 15 equals negative 5 times 0 plus 3x. This time the negative 5 times 0 is 0. And so we have 15 equals 3x. We'll divide both sides of the equal sign by 3 and get x to equal 5. A line can be drawn with only 2 points. And we have found 2 points for line D. So 0 going left or right, not going left or right at all, and going down 3, this is our y-intercept, and back to the origin, go to the x value of 5, and do not go up or down to any y-coordinate with value other than 0. And this happens to be the x-intercept of our line. And I will try to graph this line D. We'll label the lines. That was line D. This was line C. This is one method of graphing lines. In the upcoming videos for Unit 4, we'll take a look at a couple other ways to graph linear equations in 2 variables. Hopefully, though, in this video, you have not only understood how to graph a line, but how to graph a point, and are familiar again with the Cartesian plane